In this video, I want to talk about describing distributions again, this time with a little bit more detail. So at first, we just described the shape of a distribution, and now I want to talk about describing the shape, center, and spread of a distribution. So here's what you need to know. The shape is still the same. Our choices are uniform, symmetric, wow. Now, along with symmetric, we could also talk about whether it's normally distributed. We have skewed left. We have skewed right. So those are our choices. Now, if our data are uniform, symmetric, normal, then the measure of center we want to use is the mean. If our data are skewed, we want to use median. If we're using the mean to describe the center, we're going to use standard deviation to describe the spread. If we are using the median to describe the center, we're going to use IQR to describe the spread. So let's take a look at the data sets we've been looking at already. We have the number of siblings here. We already found the mean and the standard deviation. The size of the standard deviation is my first indication that this data probably shouldn't be described. The center of the data probably shouldn't be described using the mean. The other indication is that the median is smaller than the mean, so it seems like this data set is going to be skewed to the right. So then I look at my histogram and I have more evidence that this is definitely skewed to the right. Looking at the shape here, we are mostly to the left with a huge tail off to the right. This is stereotypical skewed right distribution. So with all of that in mind, if I were to describe this distribution, I would say this distribution, this data set is skewed right. I would use the median and the IQR to describe the center and spread. And so that's what you say. So if it's skewed, you're using the median. If you're using the median, you're using the IQR. If it's uniform or symmetric, which normal is a specific type of symmetric distribution, I would use the mean for the center. And if I'm using the mean, the standard deviation is the measure of spread. So we look over at this second data set. We know that the mean is 198. I can quickly find the 5-number summary just because I'd like to practice doing that anyway. So if we have our min, Q1, median, Q3, max, just in case I were to need the IQR, I'd like to have it. And so it's always good to go through steps a second time. So to find the min, to find the quartile, there's a quartile inc function. This takes 2 arguments, the data set, and then which quartile I want, separated by a comma. The median, and then Q3, again, quartile.inc, this data, the third quartile, and then we have our max, which is there. So my first indication on the shape of this distribution is that our standard deviation is quite small compared to the mean. So that tells me the mean probably does a good job of describing the center of my data. The mean and the median are super close together. So if that's the case, I might as well use the mean anyway. But then I look at the data, and this looks very symmetric, actually Normal, we've already discovered that this is normal because it follows the empirical rule. And so if I were to describe this data set, these data are symmetric / normal with a mean of, what was the mean? 198.13 and a standard deviation of 29.96. Now, you don't actually have to say the numbers. You can just say mean and standard deviation, but it's nice to have this information. What I don't want is I don't want you to just tell me the number. Like on this example, I wouldn't have wanted you to say these data are skewed right, the center is 1, and the spread is 1. I want you to tell me that you're using the median and you're using the IQR. If you were going to use the mean and the standard deviation, you would say a mean of 1.72 and a standard deviation of 1.37. So again, symmetric data. Where did I put that little list? Oh, here. If the shape is uniform, symmetric, normal, mean and standard deviation, skewed, median, and IQR. And that's how you describe a data set in more detail.